we will talk about the structure of cement. In pulp, we have different layers. From outer to inner side, we have the odontogenic area and normal structure of pulp. What is the odontogenic area? Look at here. This part is our predentin area, and dentin starts from this part. Here is our border between the dentin and pulp. In outermost layer, we have odontoblast cells. A little in the inner side, here you can see, we have a gap. This gap known as the cell-free zone. And in the innermost side, we have another layer, which reach of cells. Be quiet. In this rich zone, we have stem cells of odontoblasts. Or you know this zone from our previous lecture about the dentin. The whole cells layer, whole cells present in this one. In all type of the tooth, or in all section of tooth, you can't see cell-free zones. And cell-free zone location depending on the stage of dentin development. In the adult tooth and in the tooth without any growing, we can see this space. But in the duration of primary or secondary dentin production, you can't see this gap very well. Because in that stage, we need to more odontoblasts, and these cells continuously transform to odontoblast, and in this area, we have cells. So, under the light microscope, when you examine the pulp structure, sometimes you can't see this free space, okay? The odontoblast cells plus cell-free zone and cell-rich zone known as the odontogenic zone. Odontogenic zone. Under the cell-rich zone, we have another layer between the odontogenic zone and pulp normal structure. This zone known as the parietal layer. In the parietal layer, we have high amount of nerve fibers, peripheral nerve fibers. You can see tracts of nerve fibers. Nerve fibers continue in this part, and from this layer, raise some branches and cross the cell-rich zone, cell-free zone, and reach to the odontoblast cells, okay? And can enter between the odontoblast cells and also enter into the pre-odontoblastic space. You know the pre-odontoblastic space? Where is the pre-odontoblastic space? Yes. Yes, between the odontoblastic process and peritubular dentin, we have this space. This space filled with dental fluid or dental lymph. This fluid continuously circulate in the dental area between the dentin structure in the periodontoblastic space. Hydrostatic structure of this fluid is very important in pain transduction. We will talk about that. Can you understand these structures? Now, I want to ask you a question. We told this zone is cell-free zone, but in cell-free zone, again you can see some cells. Which cells can find in cell-free zone? Look at here. What is this structures? Blood vessels or capillaries come from the middle side of the pulp cross the cell-rich zone, cell-free zone, and reach to the odontoblast. These capillaries, as you know, have endothelial cells, and also you can see some connective tissue in outer side of the blood vessels. Okay, so when we talk about the cell-free zone, it's not actually without any cell. Okay, we have some cells in this one, and in the inner side, for example, in this part, we have a loose connective tissue known as normal pulp. In this loose connective tissue, we have all the structures of connective tissue, like collagen fibers, generally collagen fiber type 1, fibroblast cells, blood vessels, nerve fibers, and immune system cells, like lymphocytes, like macrophages, and the neutrophils, basophils, and astrophil cells. Okay? When we look at the structure of pulp, here you can see the main structure of pulp in the middle side of the tooth, and this pulp continue with this narrow structure. Again, this narrow structure, in this narrow structure, again we have pulp cells. And in the end piece of the pulp here, and in this part, we have the apical foramen. Let me back to this part, and you know this is part from our dental lecture. Again, here you can see this odontoblast cells, cell-free zone, and cell-rich zone. Sometimes, in the formation of apical foramen and radicular side of the pulp, you can see some anomalies. Normally, in two-root teeth, we have two pulp in narrow side, known as the radicular pulp. But sometimes these pulps open into the side pulp with accessory channel. This accessory channel very important in root treatments. And these accessory channels hardly distinguishable by X-ray, and sometimes you can treat the root part very well, but you can give the good results. That because of these accessory channels, okay? Because these accessory channels have a structure like pulp in this part. Okay, you can see the amount of or volumes of pulp in different teeth. You can read this part for yourself, not important for histology lectures, but you can read this part for yourself. Here you can see the pulp in formation period, undeveloped root, and this part is our pulp, and here you can see our hair wing membrane or epithelial diagram. This diagram goes to closer and closer and close the root side pulp. In the right side, you can see the closed area, radicular pulp form, and two ends of the teeth closer to each other. And we have a small foramen here, known as the apical foramen. From this apical foramen, our blood vessels, lymph vessels, and nerve fibers can enter into the inner side of our teeth. An important thing related with the apical foramen, in this part we have pulp, and here we have the dentin in the inner side. In outer side, again here we have dentin, and dentin covered with cementum. In the apical foramen, this cementum a little enter into the inner side of the apical foramen and cover until this part. And again here you can see this cementum cover a little apical side or beginning side of the apical foramen. This covering is very important. Why? Because if cementum not completely cover this part, the fluid of dentin can go into the outer side of the teeth, and you can protect the dentin fluid in the inner side of the dentin. Okay? Again, here you can see the apical foramen in this part with a little anomaly. You can see this anomaly with a little transverse structure. And again, here you can see apical foramen, instead of formation in the straight way, it forms directly in side part and open into the periodontal ligament, and inside part you can see the alveolar bone. This is the side shape of the apical foramen. Okay? Again here you can see our apical foramen in this part, but this could be closed, and our teeth can nutrify with only accessory channel present in the middle side of the teeth. Here you can see the accessory channel. Or again you can see in the root parts we don't have complete radicular pulp, and our apical foramen open from the accessory channel in this part, and from this part our teeth can nutrify. Okay? And under the X-ray, you can see this structure. Here is our pulp, this part is our radicular pulp, here is our coronal pulp, and in the inner side here, you can see this accessory channel, like this channel. Okay? This is our accessory channel. Can you understand these structures? Very important. This accessory channel is very important in treatment. Here you can see the loose connective tissue. You know the loose connective tissue structure and fibroblasts and other things. I don't want to teach you again the structure of loose connective tissue. And here again you can see a fibroblast under the light microscope. In this part you can see blood vessels, and in the inner side of blood vessels we have red blood cells, and you can see a macrophage. Here you can see the granulocytes, and in this part you can see the plasma cells. Again, plasma cells can found in the pulp. What is the role of plasma cells? You don't know the immunology. Because of that, in this part you can't answer the question. Plasma cells actually is our activated B lymphocytes. B lymphocytes, after activation, change it into the plasma cells and start to produce the immunoglobulins. Different types of the immunoglobulins have a role in the immune response against special antigens. And here you can see our plasma cells. The matrix structure, in this matrix we have structure like connective tissue. We have different types of the collagen, generally type 1 collagen, our abundant collagen type, and also we have type 3 collagen in high amount, and also we have non-collagenous proteins like proteoglycans, glycosaminoglycans, and other structures. And you can see growth factors and etc. Here you can see the distribution of blood vessels in the pulp. All of these structures is the blood vessels present in the pulp. Again, here you can see these blood vessels branched from the main blood vessel and form this capillary network. Here again, you can see the pulp of newborn, and you can see the pulp of infant in the child stage, and this is the pulp of adults. What is the differences between the pulp of newborn, infant, and adult? What can you see, and why these differences present? Because in infants, our teeth not grow completely, and in our teeth we have high amount of formation of dentin, formation of enamel, formation of cementum, and these periods continue. Because of that, we have very active pulp, and in this pulp we have high amount of different cells. But with completion of the structure of dentin and teeth, our cells and our pulp tissue volume goes to decrease within 9 months, and in adults we have only normal loose connective tissue in pulp with very little function. Okay? Here you can see the distribution of the blood vessels. You can read this part for yourself. Again, you can see blood vessels, the branched part of the blood vessel in the pulp. Again, you can see our blood vessels, capillary plexus. And in this schema, I'm showing to you a picture from the confocal microscope. And for capture this picture, they use different dyes. They use special dye in blue to stain the nucleus of the cells. This area could be our odontogenic area. And also they use another stain in green to stain the peripheral nerve fiber. With this method, you can see high amount of nerve fibers just under the cell-rich zone. This zone is our parietal layer. Okay? We talked about the parietal layer. And again, you can see the pulp structure with distribution of different nerves in side part. Here is our dentin, here is our pulp. Could you see this high amount of nerve fibers in the odontogenic area? Here we go. And again, in this part, we can see our cell-free zone, odontoblast cell layer, cell-rich zone, and what is the name of this layer? Parietal layer. Again, you can see same structures. Look at these nerve fibers and in this. Okay, now we are going to talk about an important thing, the pain transduction in the dentin and teeth. How this pain transduction? We have 3 different theories related with this pain transduction, but the third one is most acceptable by researchers. In the first theory, we have dentin directly innervation. In this innervation, some nerve fibers cross the odontoblast and enter into the area of peritubular dentin or peritubular periodontoblastic space. Sorry, the periodontoblastic space. And here we have the peritubular dentin. And in this space, pain-induced molecule can directly induce the nerve fiber, and from this nerve fiber, pain can transduct. In the other theory, the pain transduced with the odontoblast. Pain induction molecules enter into the cytoplasm of odontoblast and transduct from odontoblast and release into the, be quiet, release into the basement part and directly induce nerve fibers which present in the basement part of the odontoblast. And from these nerve fibers, the pain can transfer. But the third theory says the hydrostatic pressure change in the fluid volume of the dentin fluid or lymph fluid present in the dentin or present in the space between the odontoblastic processes and pelvicular dentin can induce the nerve fibers which present between the odontoblast in this part. Okay? This theory now accepted with more researchers than the other theories. Can you understand the theories? Now you can understand why, for example, in the anomaly of enamel related with the odontoblastic process. Can you remember that anomaly name? Enamel spindles. In that anomaly, why our enamel is high sensitive? Okay? Because that parts continue directly with the transduction system and directly with the dentin fluid. Do you have questions from this part? Here you can see our odontoblasts and the nerve endings present between the odontoblasts. We talked about these nerves or these nerves. Look at this part. Here we have the nerve endings, and in this part we have the odontoblastic processes and odontoblasts. Again, here you can see the connection between the peripheral nerve, here you can see, and odontoblast. This part is our connector A. Here you can see the aging of pulp, and we talked about that. As you can see, the pulp volume by increasing the age goes to decrease, and the amount of cells again decreases by the increasing the age. Here you can see the volume of a pulp decrease. Look at this part. You can see in this part the pulp volume decreases. Look at here. Again, we have we can see the volume or amount of volume between this pulp area and this pulp area. You can see the decreasing of pulp level. In this part, you can see the pulp stones. Pulp stones. Sometimes in the structure of pulp, you can see some stones like these. These stones, also known as the denticle. Denticle. Structures like dentin, present in the inner side of the pulp. This is because of the some transforming structure of dentin or odontoblast, and these structures can form in the middle side of the pulp. Again, here you can see a pulp stone, and again here you can see these stones. These stones present in the pulp, and when you trying to treatment or trying to do or enter some things into the inner side of pulp, you can see these pulp stones, or you can contact with these pulp stones. Again, here you can see the pulp stones. Here again we have seen the calcified structures in the pulp area. And that's all. Do you have questions about pulp? Very easy. You can give at least 2 points from pulp. Okay, let me give a break. And after 10 minutes, come back